So generally speaking, what we're going to be working with today is a situation where we're going to be talking about an 11.2. We're going to be talking about reaction types. And so the reaction types are as follows, basically. Combination, I'll also refer to combination as synthesis. You'll have combination. If you all look in your book, all of these are kind of illustrated. You have decomposition, single replacement, double replacement, so single replacement, double replacement, combustion, and acid base. I don't think your book goes into acid base, and I'll probably let you all know today that they exist. I'll probably spend some more time later on talking about how we determine them. And so if you look, your book gives you a breakdown of basically 5. I normally do about 6. But what's really happening with those acid bases is that you normally end up with a salt, or you end up with water or something like that. Salt and water is basically what you end up with. And so the way that we define these, let me make sure that I can give you all a clear view of these. So the first type that we need to discuss, combination. Combination synthesis. You have A plus B yielding AB. Okay? So A plus B yields for you AB. Decomp is the same thing, but just in the opposite direction. So AB yielding A plus B. Now, these are just general definitions of how these reactions take place and what's going on with them. What I will do later is be a little bit more specific about what's going on with all of them. Single replacement. You got A, B plus C yielding AC plus B. And then in a double replacement, you've got A, B plus BC yielding AC plus DB. Now let me be clear about something. Notice that I replaced these with only the things that were on the proper side initially. And that's going to be something that we'll have to discuss here in just a moment with how we know what's an AC and DC and how do we determine where they're going to fall on this. All right. So so far that's 4. The other one that I'm going to deal with today is combustion. Yeah. And when you're talking about combustion, really what you're taking a look at is going to be some type of hydrocarbon, like a CH, C is X, H is Y, plus O2. It's going to end up yielding H2O plus CO2. Carbon dioxide and water is what you end up with as your products in a combustion reaction. Hold on just a second. Let me rewrite that one. So CXHY plus O2 yields CO2 plus H2O. So carbon dioxide and water from the hydrocarbon and oxygen. Generally, all of these guys initially are normally going to be in the gaseous form. As the water cools down, it will become a liquid. So those are the 5 we're going to focus on today. So we have those 5 that we're going to focus on. Let's see what time. At 8 minutes. So I'll probably get done with synthesis and decomp, and I may have to come back and do another video on the other ones. So for synthesis. You had H2 plus O2. It would yield H2O. Now, if you're talking about H2O, this is what it yields and what it produces. Always remember that this has to be balanced. So you've got H2 and O2 and 2. So this guy is balanced. And this tells us that it's a synthesis reaction because you start out as 2 separates and you end up as one single whole. On a decomp, start off with H2O2 and it yields H2 plus O2. 2 there. And you just notice that you go from having one single and it becomes 2 different individual atom types. That didn't show up on the bottom, did it? So once again, you start off with H2O, and the decomposition, what you end up with is H2 plus O2. And so with that being said, that's a decomposition. So I'm going to stop there and give you all a chance to work with that. I'll post this lecture and let you all practice with the stuff that you all have to from the book.